Hello, this is Mike Lively and this is Professional Paper Vision. And today we're going to finish up our discussion of zSorting. Now we won't finish zSorting, we'll have a few more videos on that, but you'll get the basics from these two videos. Now that means you need to go back and watch the first one, or some of what we do here may be a little mysterious to you. We're going to look at two programs in this discussion, the torus worm, which we've already discussed, and one that Adobe created. And this is a beautiful example of polymorphism. But they do something bad here, and we're going to show you what it is and tell you not to do it. So let's get started with the torus worm first and show you a number of zSorting algorithms that I've created for it, and then we'll look at Adobe's example. We're back in CS4 Flash, and we're looking at the code for the torus worm. Now, if you don't recall this code, if you haven't seen it yet, make sure you go back and review the video on the torus worm particle systems. This will bring you up to speed because we're not going to go through it again. But what we do want to realize is that when we created our torus worm, we actually shoved all those particles into a particle underscore array right here. That's very important because on each iteration, we're going to update that array based upon a trajectory that we're making around a torus. And here's the equations for that. But there's a problem. As your torus worm begins to go around your torus, it changes its z. And as it changes its z, it loses its ordering. So the particles get mixed up and the layering gets confused. And so what we want to do is write an algorithm that will resort that array based upon its z position. And I've written a simple one here. So you take the particle array that you've put all your particles in and you sort on z. And you do it numerically. And then you use this pipe connector to connect in descending order. So you're going to do a numerical sort in descending order, so 0 on up. So basically, once you've sorted your array, then you put it in a for loop and you restack it using the set child index. So here's the name and here's the index, and you just run through that for loop. Now there's a problem with this, and the problem is you're doing double duty. Take a look at this. You got a for loop here, a sort, and a for loop here, and that just loads your processor. So I don't like this approach. This is the most popular approach. But sometimes you can look at the algorithm and see if there's a different way. We'll look at a few more and I'll show you a different way to do this. It's not the most optimal way as far as perfect z-sorting, but you really can't tell the difference visually. Let's run this and then we'll go to the next scenario. There you go. Here's z-sorting. So and it looks like you're going around the torus. Just fine. Let's take a look at the next example. In this example, we're just going to sort using add child. So once again, the same arrangement, sort on z, array numeric, array descending, and you just tick through the particles using add child. Let's run that. Now I actually don't like this technique as well because if you have another element on the stage, you can really mess it up. And so I really like the index so I know exactly where it's going. But it is another way to do it. Okay, let's comment that out and go to the next one. In this one, we're going to use add child at. And so let's uncomment it. And pretty much you're using, once again, sorting on z in numeric order in descending order. And then once you do that, you pretty much add your child at the specific index. So at this point, you're probably asking, what's the difference between add child at and set child index? Well, they pretty much both do the same thing, but you can think of one as working with the display object and one as working with the index. Okay, let's go ahead and run this. And once again, you have your torus worm circling your torus. And as was shown earlier, the method here has the same problem as all the other methods we've shown you, is that you're doing double duty on your processor. You have a for loop here, and you have to sort, and you have a for loop here. So is there a way actually to do the sorting within the particle loop itself when it's updating? And there is, and it's not optimal, but you know what? You're not going to be able to tell the difference. So let's go ahead and comment out this particular method and show you the other one. Now the method we're about to show you, you're not going to find in a textbook anywhere, and someone's going to call it bad, and it's not going to work for every situation, but it's a method using swap children. And let me comment this out so you can see it. And now what I'm going to do, I'm actually going to look at my particle array and just say, what is my particular scenario? And that's not basic. I'm just ticking each particle every time I go through this loop. So what I want to do is just compare the first two particles, 1 and 2, and see if the z order has changed. And if it does, I'm going to use swap children to swap them. So basically, if I push one down, let's swap it. And I do that through the entire particle chain as I iterate through the particle iterations. Now, in this, of course, things can get out of whack, but let's see how it looks visually. And you know what? It looks the same. Now, this isn't going to work for every example, so what you need to do is do your best to keep yourself from double processing if you can. And so if you can look at your algorithm and say, you know what? I can do this using another technique and get that z-sorting going, and it'll still have the same visual effect, you're good. If not, well, you're stuck with double processing. But remember, there's always more than one way to skin a cat. So make sure you turn on the thinking cap. So now that you've seen some examples of ordering the Z layer, let's take a look at how Adobe is doing it. Here's a beautiful example of z-sorting that Adobe has created, and you can basically see you've got a cube and they put circles around this cube, and as they rotate with the mouse, basically the primitives or the circles are reordering. And if that wasn't the case, then as you rotate it, they would actually get messed up, and the further one away would look on top, and the one that's supposed to be on top would look on bottom. So it's basically the same scenario we've described, but there's some issues with this particular example we're going to go through. Let me show you the code real quick. There's actually 3 classes, and there's actually the CS4 flaw file that it runs from. Now, we've already done some videos on classes and how they're constructed. We haven't worked with them a lot, but we will be in Chapter 2, so we're not going to go through everything in detail. But I want to go through the class that does the sorting, and that's the box 3D. So let me click on that real quick and tell you what's wrong with this class. If you go to the bottom of the class, you're going to see a reordered children. That's our sorting algorithm. That's good. And there's 6 objects involved in this ordering. There's 0 to 5 because it's less than 6, and you're indexing through those. But look what they do here that's wrong. You want to treat your system as a recyclable particle system. You do not want to remove children and add them, because what Adobe has a problem with, because Flash has a problem with trash. It does not collect its trash correctly, and it can kind of hang around. And so if you've got resources that are building up, and then eventually the trash collector comes along and pulls them away, you're going to have to get this oscillation in the way your CPU is handling these resources. So you don't want to remove the children. Okay, that's the first thing. All right, let's go down here next, and you're using the add child, which if you have other objects on the stage, that's going to mess things up as well. So let's get rid of that, and let's use set child index. So you're going to reorder upon index, and so as opposed to removing and adding your children to the stage, you're going to be reordering where they appear in the display list, and that's exactly what you want to do. Recycle your particles if you can. Do not add and subtract them. You're going to have problems with trash collection if you do that. So let's go ahead and save this and run it and see if there's any difference. And here it is, and it looks exactly the same. So I encourage you to go through this example and look at the different classes. They're all in the download package for the source code. But as we proceed to the chapters, I want to come back to this, because this is a beautiful example of polymorphism. You can put anything you want in for these sites. You can put video, you can put square, you can put different objects, and it's all due to the way Adobe has set up its OOP programming. A great example. We'll come back to that. Okay, that's z-sorting for now, but we're not done with z-sorting, because in the next chapter video, we're going to build a carousel.